It's high time we sort that enclosure out.
Let's do this.
Coming real, it's the next episode.
Hi, welcome back to NERDVille. So in my last 3D printer video, I upgraded the copper bed and there was a lot of positive feedback from that. In fact, in my whole channel, that one has had the most views, which is very encouraging. Now, in that episode, I talked about doing a unique enclosure design. Well, it's high time we set that up and get on with that project, because I think this is a very unique one and I feel that it might even get ripped off by some 3D printer companies. So today we'll be joined by our two young nerdlings. I've got version 1.0.
Hi.
And version 2.0.
Hi.
Let's begin. So why do we need an enclosure? Well, we need an enclosure because we'd like to have improved prints with the ABS, as well as other temperatures that are very sensitive to temperature variation. Now, one of the biggest issues with ABS is a warping. What happens with that one is, as you lay the first layer down, that's nice and warm. As the second layer is printed, the first layer cools down and slightly shrinks. And this will happen with every subsequent layer that you lay down. And in turn, each layer then starts pulling the previous layer up with it, and then you get warping, and the actual print then itself will detach from the heated bed, which is not ideal. What you want to do with ABS and other materials that have that sort of similar sensitivity to temperature is keep its environment constant. Now, looking at this 3D printer, you can't keep it constant if it's got very large apertures that just get rid of the heat. It's good for PLA because PLA is not so sensitive, but not so good for ABS. So an enclosure is what you need. Now, there are enclosures designed for this 3D printer, and to be totally honest with you, they look a bit clumsy. They've got really long roofs like that over it, and it's just kind of, in my opinion, doesn't look very good. And I thought to myself that, yeah, we can improve the design of that enclosure. So some of these files that you can get for this printer are available on Thingiverse, which I will use. And predominantly, I think I'll keep the sides and the front same. The front will be detachable, so you can get access to the 3D prints. And the top is what I want to change. I don't want the roof, I want something completely different. There is a concept that came into my head, which is very similar to a camera iris, where the aperture has several leaves that when they slide open, the hole gets bigger, or the aperture gets bigger, and when they slide together, the aperture gets smaller. But here, we can't have that. What we need is the actual aperture. It has to move wherever it's going to go. And I think the only way you would describe that is it's a kind of a two-dimensional bellow, as they would have in CNC machines and so on. So let's take some measurements. Let's jump on the CAD machine and let's see what we can knock up within the envelope and see if it is a feasible project. If it works, then we'll just laser cut it, assemble it, with the help of my two nerdlings here, and we'll see what we get. Okay, so these are the files you can download off Thingiverse. It's basically the profile cutouts to create the frame for my 3D printer. These parts here in green are the actual enclosure design that you can get from Thingiverse. So this would be the sides and this would be the front. Now at this stage that doesn't concern me, so we can get rid of that. But this, on the other hand, is what we are concerned about. The black bit is the profile to have the cutout for the top frame where the Bowden shoe would come through around here. The heated bed sits around here, and this is what is the printable area. But the printer head, this is the area it needs to access to be able to print on this heated bed. I've also put a red boundary around here because this is actually produced from the frame. So this is something that I need to design around when I come to creating this Iris design enclosure for this 3D printer. The first thing that we need to do is we need to prove the concept, and before we can even go into any complicated CAD work, we'll use a two-dimensional vector program and just scale out to see if it is even remotely feasible that we can create a two-dimensional bellow. The black area in the middle is the travel envelope of the printer head nozzle. Painted it black because it's easy for me to see when we start adding the layers. Now off camera I've spent more time than I think I was going to spend on this thing, and the intention was to use as few leaves as possible because I don't want to create a tall stack, and I have to keep in mind that there might be friction as well, although I think it'll be minimal because it's acrylic at the end of the day. After an exhaustive amount of hours, it turns out I need exactly 6 leaves to create my two-dimensional bellow. Now the first layer, what it does, it would cover up majority of the dead space. So this is the frame. Between the frame and the envelope of the nozzle travel is dead space. The second one will travel in a horizontal fashion from one extreme as it cover up half of it, and the other extreme. All times it will stay within the package envelope of the first sleeve. It's probably worth mentioning that the acrylic is going to be, I believe, 3mm thick, so already we're 6mm up, and onto a 9mm is our third layer, and this also will travel horizontally like the other 2 leaves. And now you can see the access to the heated bed is getting even more smaller, but at all times it's covered up a majority of the aperture. Bring in the 4th leaf, which now makes it 12mm. Move that into position, and you can see it's got another 25% smaller, that opening. The 4th leaf is going to travel in a vertical travel, and because it's 9mm off the face of the frame, it can actually go over, and it's allowed to overhang, and on this side it can also overhang, but we are going to miss these brackets here at the top. Bring in the 5th leaf, making it 15mm. Now these two are designed to move vertically as well. They'll be constrained with possibly some guide rails, which will be fixed onto the 3rd leaf. And finally the 6th one is the last one, which is a disc. And as you can see, I've made the center 30mm, which is enough space for the bowden and the wiring that goes to the extruder to come through. And the reason it's a disc is because it has a total freedom of movement within that space if it needs to. And the way I can test this to see if it's going to work is we need to move the nozzle to its 4 extreme positions, corner to corner, and to see if the leaves are going to interfere outside of the packaging envelope. So we'll move the nozzle there and see if we can get this bit in the middle to be black without it encroaching this space on the outside. I must explain, when we move this, there'll be a tube that will hit this internal edge, and that will in turn push that way. The next leaf will have an internal edge, and that will push that way, and so on, and so on, and so on, until all the leaves are moving. So that's the way mechanically how that's going to work. But if we try it in the 4 extremes, let's see if it clears everything and it's all going to work. I've obviously done this already because I know it works. And finally, there's an opening here. If we move this across, this moves in a linear fashion. Voila! We are accessed to the print bed, and there's no other black space in there, which means it's covered. Now the good thing is we've got this large black slot in the middle. If this wants to go up and down, it doesn't have to move these 3 leaves, it just moves the 3 leaves, the 3 top leaves. So let's say the nozzle wants to go down to the bottom extreme, and the 2nd leaf will get moved down, the 3rd leaf will get moved down as well. And you can see that these 2 leaves are allowed to go outside the space, but they're still within the space of that enclosure. And I can see black space there, and nowhere else is it encroaching as well. So we might as well go to the final position, see how that looks on that corner there as well. Again, the nozzle disc is clear, nothing's interfering it there. This will get dragged across as well, so will this, and finally so will this, because these two will be within vertical guides, so it means that this will get pushed across as well. And there we go. Oh, wait there, this as well. We've just proved the concept. It does work. Now, let's bung this into the 3D CAD and let's see if we can actually get this physically working within there before we go and start laser cutting everything. Okay, I've brought the initial concept sketch that we had in our previous clip into the 3D design. And we started off with our enclosure top frame, which gives us the package envelope of where the leaf can only operate within. So we want to operate within this parameter here, and also we don't want to go beyond that extreme there, certainly for the first 3 leaves. Now if I bring in the first leaf, which will basically cover up the bulk of the area that we want enclosed, that will do it nicely. Now the next bit here is it's got slots, and those are for horizontal rails. And the horizontal rails will be mainly used for leaves 2 and 3. There we go. And they will again make that area that has access to the printer bed even smaller. And leaf 3 also has some rail slots, and these are for vertical rails. And they'd be used for leaves 4 and 5. There we go. And as you can see, if I zoom right in, oops, it has a 1mm clearance from the top of the rail to the top of the leaf 5. Now the last leaf is a disc, and that basically encloses the complete top of the 3D printer frame. So now I don't have a box, a large box that covers my 3D printer enclosure. I have something that is only, if I measure it, 18mm high, which is pretty damn good. Now the only thing is, before we laser cut this, let's just prove that it works in 3-dimensional as well. So I'll bring up the hidden geometry below, and you can see this where this filleted square is the actual copper bed. Now if I move these components across, we always want to be able to see this orange circle in the middle, which is the copper bed. Now I'll start with moving this one to its furthest extreme, and we can see that's within the confines of our package space of the top frame of our 3D printer. When this one moves across, you have to appreciate that there's going to be a cylinder within that, and that will be attached to the extruder. So as the extruder moves, it'll take the cylinder with it. The cylinder will engage with every internal surface of the leaves that it comes across. So the first one it will move is the top leaf, then it will move the second, and it will move the third, and it will then move the fourth as well. And there you can see, I can only see orange there, and everything else is covered, and we're at our bottom left extreme. Now let's do it for the other 3 corners. That's leaf 2, and the previous one was leaf 3. There we go again. Everything's still covered. I can only see orange where it's supposed to be, and also the disc as well within the confines of its package envelope. Now the other good thing about this is that if you've got a small component, not all the leaves will move. It will be mainly 1, 2, or possibly 3 that will move. So there won't be much friction over these acrylic surfaces, I guess. So we go to the third extreme, and that will drag everything across, and we're on to leaf 4 here. If I drag that one across, as you can see, it's covered. And we know that's going to work for this one. That's one, and there we go. So I'm quite pleased with that. I think it's going to work. It's fairly thin profile, and I'm very pleased with that. Good. I think we should go on to laser cutting. Okay, so my favorite part of this process is assembling everything and finally getting to see everything working. So before I begin anything, I'm going to get some cleaning products because some of these are a little bit dusty, and I'll be right back. What? Who did? I wanted to build that. Oh.
I've never wished on God, hope did it never
you enjoyed watching this episode as much as we enjoyed making it. You know, there's been some real surprises with this design, and I had this idea almost 6 months ago, but it just taken me this long to implement it because of my workload. And one of the side effects that I hadn't thought about was that how quietly the machine runs now, because it's enclosed. And as you saw from that 3D print, the actual NERDVille logo that I created was actually quite large, and it was fairly thin as well, and there was zero warping on that. And you know, I think this is a design that could be used with any other 3D printer that has a frame-like enclosure and has apertures at the top and the bottom. So, you know, it's a real success and I'm really pleased with it. Stay tuned to this channel because I have an announcement that I'm very excited about in the next episode of 3D printing, and I can't wait to share it with you. Well, it's goodbye from me, and it's goodbye from Nerdling version 1.0.
Bye.
And it's also a goodbye from Nerdling version 2.0.
Bye.
Thank you for watching.
That's not cool anymore. Did it now?